Hi, my name is Kriti, and today I'm going to be going over day 3 pre-calculus problems. So first, given the rational equation, we have to find the wholes. Since x1 is on the top and the bottom, we know that our first whole is going to be 1 because we just take the opposite. And then if we plug in 1 for all the x's, 1 plus 2 is 3, 1 minus 3 is negative 2, 1 times 6 is 6, so then we would have negative 6 over 6, which is equal to negative 1, so our y will be negative 1 for a whole. For our vertical asymptotes, we can just look at the bottom. So since it's just x, we know that there is a 0, and then x plus 5 is just equal to 0, which gives us negative 5. For a horizontal asymptote, we just check if it's bottom heavy or top heavy. It's neither, it's equal. So then we look at the coefficients, which are both 1. So our horizontal asymptote is y is equal to 1. And our x-intercepts, we look at the top. So we just put both of them to 0. So which gives us negative 2 comma 0 and 3 comma 0. And we have no y-intercepts. So now for us to graph, first I would graph the vertical asymptotes, which is 0 and negative 5. And then I would plot my x-intercepts, which is negative 2 and 3. And now we just check so to see if the graph will go this way or this way. So I'm going to check for this point. So if I plug in negative 1 for the x's, it would be negative 1 plus 2, which is negative 1 plus 2 is 1. Negative 1 minus 3 is negative 4, which gives us negative 4 on top, and then negative 1 times negative 1 plus 5 is also negative 4, which gives us negative 1 times 1 plus 5 . Okay, sorry, if we take 1, so then 1 plus 2 is equal to 3, and then 1 minus 3 is equal to negative 2, so then 3 times negative 2 is negative 6 over 1 times 1 plus 5, which is 6, so it's kind of the same scenario here, which gives us negative 1, so we know this point is right. So now we can tell that the graph goes this way. And since they both are squared on the top and the bottom for the equation, we know the other graph's going to go like this, and the last graph would go like this. So next, it says, given the logarithmic equation, simplify using properties of logs and graphs. So here, what we're going to do is, so if we combine them together, we would get log 2 times x plus 4 over 4 plus 7, because we divided these two and then multiplied this and just added this on the side, which if you would simplify that would give you 2x plus a over 4 plus 7. And if we want to simplify into this form, we would just make it into it would be x plus 4 plus 7. So that would be our simple logarithm of 4. And next, to graph our point, we know our vertical asymptote is going to be negative 4, because over here. So let's graph that. So 1, 2, 3, 4. And we know our point that we're going to base our points off of is going to be negative 4 comma 7. So 1, 2, 3, 4, 5, 6, 7. And then we can make our little t-chart. So if we had 1, 0, 10, 1, 100 to 1 over 10, negative 1. And then all we have to do is multiply the x by 2 because it's a horizontal stretch. So this would be 2, this would be 20, this would be 200, and this is going to be 1 over 20. And yeah, and then we can graph this. So if we graph this, we're going to get, so from this point, basically, that's not a point, but it's just what we go off of. So we can do 2, 0, so be here. And then I will put into a graphing calculator to find the other points. So we could say another point when I put into a graphic calculator is like here and here. So it will never go on 4, but it'll be very close. So then the graph would go like this. So now we know that our domain is -4, infinity. And our range is -infinity, infinity. And then for end behavior, we would do as x is equal to -4, y is equal to -infinity, and as x is equal to infinity, y will equal to infinity too because of it. And we already found our asymptote, and our pivot point would be -2, 7, because that's one of our points right here. So next we have to find our inverse. So to find our inverse, let's first write down our already known function. So now we have to flip the x and the y. So x is equal to log 1/2 y plus 4 plus 7. So we take the 7 to this side. So x minus 7 is equal to log 1/2 y plus 4. And then we have to flip the form to exponential form. So that would be 10 to the power of x minus 7 is equal to 1/2 y plus 4. And then we times 2 to get rid of this, times 2 here. So that would be 2, what do we do? 2 times 10, x minus 4, minus 4, because we would just take this to the other side now, is equal to y. So this would be our new function. And since it's an exponential form, we know that our asymptote is going to be -4 again, but it's going to be horizontal. So if we plot our -4, so 1, 2, 3, 4, so this would be our horizontal asymptote. And then next we can make our, also we know our point is 1, 2, 3, 4, 5, 6, 7 here. And then we make our pattern again, but this time it's flipped because it's exponential form. So then this time we would change since this is a vertical stretch, we would change this section, we would multiply that by 2. And then if we would plot this, be here, and then we could also put this into a graphic calculator. So then we would get here, a point here, and here, a point here. And our graph would look like this. So we know that our domain is going to be -infinity to infinity. Our range is going to be -4, infinity. Our end behavior would be as x is equal to -infinity, y is equal to -4, and as x is to infinity, y is also to infinity. And our pivot point, again, here would just kind of be the opposite for our last one, so -2, 7. Thank you.